Hello and welcome back to my favorite people, and thank you very much for watching this lecture video. We're talking about carboxylic acid, and in the last couple of lectures I showed you how to get a carboxylic functional group, and one of the method was the hydrolysis of nitrile. And the nice thing with the nitrile is that when you kick in any halide group or any living group by a cyanide, and that's going to give you a chance to extend technically the molecule by one carbon, and there will be a triple bond between carbon and nitrogen. And that triple bond is going to be weakness of the system because it has a pi bond. It can go through some chemical reaction. And for example, we can run hydrolysis in acidic solution in order to turn it to carboxylic acid. Another method is going to be reaction of Grignard reagent with CO2. We know Grignard reagent is going to have a lone pair or negative charge on carbon. That means it's going to be a strong nucleophile, and a strong nucleophile very soon is going to find any electrophilic carbon and it will attack it. And if I treat that one then with acidic solution, that's going to give me an acid or carboxylic acid. Let's go after it. So the first step of this reaction is preparing the Grignard reagent. The Grignard reagent, you need to have an alkyl halide reacted with Mg, and Mg technically is going to replace the halide, or it will be inserted. Mg, it will be inserted between these two, between carbon and between carbon and halide, and so you will have Mg bridge, and Mg or metal, because it has less electronegativity than carbon, or the halide is going to have a positive charge and carbon is going to have a negative charge. Now, what's the role of the diethyl ether? That's just simply is the solvent of the reaction, so it's not going to get involved inside the reaction. So first step, but we will get this intermediate, and that's going to give us the nucleophile. Now the nucleophile, it can attack the carbon dioxide. So if we write the nucleophile, we will have a carbon with a lone pair, and then we will have, I can write the Mg somewhere here. So we have Mg with, let me write it close to it, have MgBr there. And then I'm going to react this one with the CO2, and the CO2, I can write it that way. And now very soon, carbon is going to attack the CO2. And now what will happen with the pi bond? Remember, each oxygen has two lone pair. One of the pi bond is going to move to carbon. So, sorry, it's going to move toward technically oxygen, and that's going to create the third lone pair and oxygen. So we're going to get such a molecule. There will be a bridge between carbon of the benzene and CO2. And now we will have a double bond between carbon and oxygen, and a single bond between carbon and the second oxygen. But this oxygen is going to have third lone pair, so that means it's going to have a negative charge. And if we treat it with acidic solution, let's say we have hydronium ion, and now oxygen is going to go after that acidic hydrogen, and it will take it, and that's going to give us the final product, which is going to be carboxylic acid. So we got benzoic acid plus H2O. So this is going to be a good method technically to put, like a carboxylic group on a ring or on an aromatic ring. And in this case, we have an alkyl halide, and our carbon is aliphatic, is a cyclic, is not aromatic anymore. And this carbon is a secondary carbon. And I want to replace the bromide by CO2, or by carboxylic group. And so I'm going to add a carbon plus 2 oxygen and 1 hydrogen. The first step, I need to, create a Grignard reagent. So the first step, I'm going to treat this one with, I'm going to say, let's treat this one. This is going to be the first step. We're going to treat it with Mg in the presence of ether. And that's going to be diethyl ether. So it's going to give us such a molecule. And what will happen with the bromide? Bromide, it will get attached to Mg. Mg, it will be inserted between bromide and carbon. Now we have a negative charge there, a positive charge here. And so the next step, I'm going to treat this one with CO2 first. Okay, so I'm going to say 1, treat it with CO2, and whatever you get, next step, after running the reaction, you're going to add acidic solution to it. And so that's going to give us this molecule. Technically, is going to be the carboxylate. Why do I say carboxylate? Because you're going to have a carbon that attached to 2 oxygen, but it has a negative charge, and that's the reason I call it carboxylate, not carboxylic acid. And next step, let's treat it with hydronium ion or acidic solution, and that's going to give us the final product, which is going to be carboxylic acid. And that's going to be the final product. Of course, we get water as well. Okay. So as you see, this is going to be a good method to technically put a functional group wherever you want. And but the thing that you have to think about in advance is position of the halide, where you put the halide, and that's going to be the key point of the Grignard reagent. And the halide, if I put it here, then my carboxylic functional group is going to show up there. And so that's the beauty of the Grignard reagent. It's going to give you the really diverse product, or different, like a method that like actually have a functional group in different positions.